In one of the videos in this playlist of calculator shortcuts of fx991MS, we have already seen how to verify whether the number given in decimal can be correctly translated, converted to other number system like octal, hexadecimal, or binary. Only the integer part, not the fractional part. We can also do the arithmetic, which is addition and subtraction. Suppose you can do the addition and subtraction in binary, or in octal, or in hexadecimal. So first we will see this. For that, go to mode, keep pressing mode till you get base. Base is option number 3 here, menu is 3, so press 3. Now we are in decimal, but we want binary, so go to binary. The number is 1001 in the example, so type 1001. You don't have to store it. You can directly perform the addition. The second number is 1110. The answer is 10111. Technically we see 011 is the sum, and this 1 is the carry out, but we get the whole thing as the answer in the calculator. There is no separate provision for sum and carry. Now we want to get the same answer if these two numbers are converted to octal. This is the answer. You can directly press octal, you can directly press hex, you'll get the same answer. Or if you want, you can also type in hex. So now we are in hex 9 plus e. For e, it is written here a b c d e. So it is alpha e, which is, sorry, it is shift e plus 9, which is 17. It is not alpha e, it is shift e. Now suppose we want to do the same thing in octal. We want to do 1 1 in octal, add it with 1 6 in octal. 27 is the answer. We can first do it in binary and then see its equivalent version in the decimal number, or hexadecimal, or other octal formats. Or we can convert each of them. For example, 1001, we want to see what is it. 1001, what is it in binary, and then convert it to octal and then add it in octal. We can do however we want. The second one, arithmetic, under the arithmetic is subtraction. In subtraction, we have two cases. One is n1 greater than n2. So we are doing n1 minus n2. n1 is number 1, n2 is number 2, and n1 is less than n2. In this case, the answer or the difference that we get after subtraction is positive, and there is no borrow. In the first years, we are usually taught using ones or twos complement method, common to most of the branches. And but the calculator will do all the subtraction using the twos complement method of addition itself, and not the ones complement. For n1 greater than n2, where the difference is positive and there is no borrow, it is very pretty simple, just like how we did. We have taken numbers 25 and 20. You can convert those two numbers which are in decimal to binary and then do it, or can directly feed it. Suppose you are doing it in binary, go to binary, then the numbers are 11001 minus 10100. So it is pretty simple. 101, so it was 5-digit number. 00, when we add it before, it will not matter, so you can take it as 00101. Now the trick comes when we are doing it for the second case, where n1 is less than n2. In theory, we are taught using both ones and twos complement, but the calculator, as I said, will be doing for both cases using twos complement. And in theory, what we do is, when we get the final answer, we again take the twos complement or the ones complement and attach a negative sign. Here the answer is only twos complement, so you have to understand that the difference is negative and there is a borrow. Again, the method is same. You type the number 10100 minus 11001. If you see here, all are ones. So the answer that we get upon calculation is 11011. Here we are getting 11011. So it is 5-digit number in binary. So 11011. These extra ones that we have indicate that the difference is negative. There is a borrow, which means first number is less than the second number. And this is the negative answer in the 2's complement. If you do the same thing in decimal, it will show it as -5. In theory, we are taught to take 2's complement of this and attach a negative sign to verify the answer. Similarly, if you want to multiply, say 25 into 5 in decimal is 125, and you can do the same thing in hexadecimal, find its equivalent, octal. These also comes under arithmetic. Arithmetic means at addition, subtraction, multiplication, all those. You can do all those also. For example, I want to multiply 9 with e. So 9 into, it is shift e and not alpha e, shift e, which is to be hexadecimal. So I change it to x. If I am in octal here, as I see, it will throw math error. So change it to hex and then press equal to. Then again I'm getting 9 into e is 7e, which is nothing but 126 in decimal, because e in decimal is 14. 14 into 9 is 126, which in hexadecimal is 7e. So you can do not only addition and subtraction but also multiplication, and this is very useful not only to verify your answers. Electronics is a common subject for most of the students in first year, so it is helpful. Suppose the given problem, addition and subtraction that we have, doesn't have any integer part or the fractional part, only then you can verify this. But subtraction you can verify only for the 2's complement method, not for the 1's complement method. Anyway, the answer will be same for n1 greater than n2. For n1 less than n2, in 2's complement and 1's complement, the answer that you get will slightly differ. That you should make a note. And here, carry and sum will not be shown separately, it will be shown as one single term. Whenever the answer is in negative, except the number of digits, the remaining digits that we have, all the digits that we have to the left will be 111, which indicates that it is a negative number.